It is the year 2022. According to Google Trends, as well as to many developer surveys, React is currently the most popular front-end framework. It has a big community and lots of resources available on the internet. On the other hand, as a Crestron developer, I cannot even imagine the future without C# and SIMPL Sharp Pro. It breaks so many limits that Simple and Simple Plus have and opens our gate to the whole new development world. In this tutorial, I will create a basic application that will combine React on the frontend and SIMPL Sharp Pro on the backend side, without using Simple Windows, Vision Tools Pro or Crestron Toolbox. I am Philip from Onion Interactive. Welcome to our first Crestron tutorial. Before we can start to program, we need to see what are the requirements for this course. For the smooth following of the React part of this tutorial, it is required that you have a basic knowledge of HTML, CSS and JavaScript. If you don't have it yet, I strongly recommend an interactive web platform called FreeCodeCamp. I suggest you finish the first two sections: responsive web design and JavaScript algorithms and data structures. After you finish it, I'm sure that you will be ready to follow this video with a full understanding. Regarding the backend side, I suggest you watch C# videos on the Crestron Technical Institute portal. It is not required, but additionally, you can watch a full React course by Maximilian Schwarzmüller on the YouTube channel Academind. You can find all the links in the description of the video. Next, you need to have an integrated development environment or shortly IDE, where you can develop your application. For the front-end development, you can use Visual Studio Code, WebStorm or any other front-end IDE. In this tutorial, I will use Visual Studio Code. For the backend development, you can use Visual Studio 2022 or 2019, Rider or any other backend IDE. Although I prefer Rider from JetBrains, in this tutorial I will use Visual Studio 2022 because it has a community version which is completely free. Node.js is the next one that you need to install. You can easily see if you already have it installed by typing node-v in the command prompt. If you do not have it, then download and install the latest long-time support version of Node. The last software requirement is that you need to install Crestron ch5 Utilities CLI. You can do that by typing in the command prompt npm install -g at crestron/ch5-utilities-cli. -g means that this will be installed globally. The last thing that you need to consider is the hardware. Basically, you can code without hardware, especially the front-end part, because you can test your code in any browser. But for the complete testing between frontend and backend, you need a 4 series processor and a touchscreen that supports HTML5 components. In my case, I will use RMC4 processor and TSW1060 touchscreen. We have several goals in this tutorial. The most important goal is to create a Crestron application that combines React on the frontend and C# on the backend. In other words, we will combine HTML5 and SIMPL Sharp Pro principles. The processor will receive 3 digital signals and 1 analog signal, and it will return 1 analog and 1 serial signal. The idea behind this tutorial is to create a basic application that will serve as a playground for your ideas, where you can experiment with your code, try to implement any third-party frontend or backend library, or it can be a starting point for your project. At the end of this tutorial, you will learn how to create a React application, work with CSS and HTML, work with React hooks, implement third-party frontend libraries, patch the node module dependency, create a script that will directly deploy the code to the touchscreen, create SIMPL Sharp Pro application, send signals between the processor and touchscreen, and deploy a code to the processor. It is important to mention that we won't cover in this tutorial, and those are React components, React router, state management, and advanced object-oriented programming techniques. This will be covered for sure in my next tutorials. After watching and following this tutorial, I strongly recommend you to watch additional tutorials regarding these topics and try to implement them. Without further ado, let's start coding and have some fun. We are now ready to create a front-end React application. First, we will create a new folder on our desktop and we will name it Crestron React SIMPL Sharp Pro app. Inside of that, here we are gonna type cmd and this will open the command line prompt with the root of that folder. Now we will type npx create-react-app crestron-react-app-template TypeScript. Now press enter and wait until the application is ready. While we are waiting, let's see what will this command do. The first part of the code is a standard command that will create a React app. The second part represents a name that we gave to the application. Be sure that the given name does not contain any spaces or big letters. The last part I added because I prefer to use TypeScript over JavaScript. There are many pros that TypeScript has, as well as cons, but instead of explaining and giving arguments, I put a link in the description where you can see the differences between these two technologies. If you want, you can dig deeper into this topic. Google is full of comparisons. After that, you can choose what's the better option for you. Back to the command. It will set up the development environment with the latest TypeScript features, and it will provide a nice starting point for developing a front-end app. Okay, the app is finally created. You can see that it created a new folder, so we need to go inside that folder. Type in the cmd cd crestron-react-app. And now we are inside the app folder. To open a project in the IDE, type code. And this will open our project in Visual Studio Code. Let's open a terminal and start the application. Type npm start and wait until the application starts. This will now start the development server, which hosts a preview of a React application. And it will automatically open up this application on localhost 3000. If it does not open a page automatically, you can manually visit localhost 3000 in your browser. Here you should see something like this. Here the details might change over time, but you should see a starting page of a basic React application which has been set up for you. Now we are ready to edit this code. But before that, let's make a quick tour over the project structure. I want to emphasize here that React code is just a JavaScript code. We are going to use React features and some special syntax introduced by React, but ultimately it will all be just JavaScript. Let's start with the source folder. we will spend most of the time in this folder. Inside that folder, we'll focus on these two TypeScript and one CSS file. Now let's start with the index.tsx file. This is actually the first code file which will be executed whenever this page is loaded. You can see that this will execute an app component where we will write most of the code. Also, we will import here index.css file which contains a general styling for our app, such as fonts, background colors, margin, etc. As I said earlier, in the app file we will write most of the code and logic for the Frontend application. But I want to mention here that we will do this just for the sake of the example. In the real-life application, app file doesn't need to have any business logic. It just needs to be a wrapper for other components. But as I said earlier, we won't cover components today. If you don't know anything about components, this will be your homework to explore it on your own. You can watch our YouTube video that I mentioned in the requirements section. Let's go back to the code. Notice this app.css import here. This imports our main CSS file where we will have all the custom stylings for different sections and components. The package.json file contains all the dependencies that we are using in the application, as well as all the scripts that we will use. Here you can see which external libraries are installed and see their exact version. These dependencies are installed in the Node modules folder, which usually occupies more than 95% of the space of the project. Usually, you should not change anything here, but we will have one situation where we will be forced to make a change, but we will do it elegantly so that we don't break a whole app. That was a quick overview of the existing code, and now we are gonna remove some unnecessary files and start writing our own code. We can start by removing the README file, which we won't use in this project. Here in the public folder, we will change some of the code in the index.html file. But please be careful. This file is crucial for the application, so make sure to not remove it. And also, if you are removing code here on your own, make sure that you know what you're doing. First, we can remove comments that are, by the way, always colored green. Now we can rename the title to Crestron React App. In the source folder, we can get rid of the test files, logo file, and this end file, which we won't use this time. Now we can clean up app.tsx file. We can remove this whole bunch of code, as well as this logo import. Rename the header title from Learn React to React Playground. Press Ctrl S to save the code. As you can see, the position of the code has changed a little bit. This is because I'm using the extension called Prettier, and I highly recommend it. You can find this extension in the extensions side menu. I already have installed Prettier Formatter, but you can type in the search area Prettier to find it. You can see a few variations of it, but click on the first result and check if this extension has more than 19 million downloads. If it has, it's the correct version. If you have already installed it, you will see this uninstall button. If you don't have this button, then click Install button and install it. When you finish this task, close the window and then click on the app.css file in the source folder. Remove App Logo section, Media section, App Links section, and Keyframes section. Don't forget to save it, and we're done. If your app was working while we were cleaning the code, all the changes should be visible immediately after saving them. If you stopped the app before cleaning it, you need to start the app again by typing in the terminal npm start and pressing enter. Finally, we can see here that we have a clean application with the header React Playground and the title Crestron React App. Now we are ready to structure the app and write some code. When you're starting to write a front-end code, it is always good to have a UI design made in Figma, Adobe XD, or some other prototyping tools that you may have. In this project, we will follow this sketch. It is a good idea to visualize a sketch as a structure. In order to do that, we divided the sketch into divisions. The division which contains everything is the app division. Inside of that division, we have one header, button list division, and slider division. The button list has a paragraph and 3 button components. Slider division has 1 paragraph and 1 slider component. You can see here that we put class name inside of every div, which allows us to style these exact divisions with a CSS code. It makes us very flexible, and you will see all of its benefits very soon. Now open an app.tsx file. Under this first div, add an h1 header and move React Playground text from here to here. You can get rid of this line, add 2 divs, in the first div, type class name equals button list. And in the second, type class name equals slider. Inside of the first div, put 1 paragraph and add a text background color. Now add 3 buttons. Name the first button red, second green, and third yellow. Inside of the second div, add a paragraph and type opacity. In the second paragraph, add the text slider. Now save it. and take a look at how it looks in the browser. As we can see, this is far from what we want to have. But our first goal was to structure the project by adding basic HTML lines, and we made it. Later we will add CSS with which we can style our application. In this section, we will implement two third-party libraries in our project. The first will be React Bootstrap library. So let's open a browser and type React Bootstrap. Click on the first link and then on Get Started. We are now on the introduction page of the React Bootstrap documentation. I recommend you to go through the documentation to become familiar with it before you use the library. Usually, front-end documentations are written in a very clear manner and with lots of examples. Documentation is always your best friend while you're developing an application. We will now install React Bootstrap in our project by copying this command and pasting it in the terminal inside Visual Studio Code. Hit Enter and wait until the library is installed. You can see in the terminal that the library is successfully installed. You can also check it in the package.json file under the dependencies. Let's go back to the browser and press Components. Under the sidebar, click on Buttons. Here you can choose which button you want. It is always good to see which properties the button has by clicking on the API link on the right navigation bar. Whenever you want to include the components, it is a good practice to look which properties does a component have. There you can get inspiration on what you can do with it, or just see the limitations of the component. In our case, we will choose this blue button. You can see that this button needs to have primary variant property. This property makes the difference between these 7 buttons. But before we implement it, we need to find how to import that button into the app. Again, press API, and you can see here the import command. Copy that line and paste it on top of the app.tsx file. Now we can use that button here in our code. So now we will replace our current buttons with the imported button. This is very important in React. When the element has a capital letter in its name, it means that this is a component, and when it does not have, then this is probably a standard HTML element like div, p, a, button, header, etc. Press Ctrl and S and see what it looks like. And we see nothing. There are no buttons that we expected. We need to think about why it is like that. Yes, we need to import CSS because it styles our component. Let's go back to the browser and go again on the Getting Started page. If we scroll down a little bit, we found a CSS section. First, look at what is written here. The following line can be included in your index or app file. In other words, if we want to style all the Bootstrap components that we will use in the application, we need to import that line of code in one of these two files. As I said earlier, app is usually a wrapper component, so it's a good idea that we import this line into that file. So let's do that. Paste in here and save it. And now we have styled buttons as we expected. Next, we need to add a slider. Go in the browser and type Material UI. Click on the first result and then on Get Started. Now we already know that first we need to install the package. So go ahead and copy this line, paste it in the terminal, hit enter, and wait until it's finished. We can check if it is correctly installed by looking into the package.json file. Yes, there it is. We successfully installed the Materials UI package. Now go back on the web page and click on the components. And then on the slider. Here you can find many nice sliders with cool features, but in this project we will use a basic slider without any fancy features. Click here to show the full source. Make sure that TS is pressed. Copy this line of code. And paste it in app.tsx file. Replace this paragraph here with a slider component. And save the file. Let's see how our application looks. And here it is. The size is not exactly as we wanted, but everything will get into the wanted shape when we will add a CSS styling. And that will be in the section that follows. You have probably already noticed in the code that inside the div element we have something that's called a class name. This is actually a reference to the CSS code that we imported from the app.css file. If we open that file, you can see this .app section. The only property that is inside those curly brackets is text line value, which centers the div element. And if we look at the browser, we can indeed see that everything is centered. So it works. The general rule here is that when you write something inside the quotation marks of the class name, the name must be exactly the same as here in the CSS file, with this additional dot in front of the name. One important thing to remember is that these names are case sensitive. We can change this name by replacing the first capital letter with a small letter, and you can now see that the code does not recognize CSS styling anymore. Let's undo that. Before we add some new code, let's get rid of that, because we don't need it anymore. Save it and let's begin. If we look at the sketch that represents our goal, the first thing that can come to your mind is that the background color is grayish. Let's add some color. inside the curly brackets, type background color, colon, and we will put sharp 282 C34. You can of course choose whatever color you want, and you can also play with other properties such as transparency. And take a look how it looks now. Well, great. Now we can see even the text as we want. So the next thing that we will add is font color. Type color and then white. Save it and take a look. Much better, isn't it? Now you can see that background color is not on the whole screen. There are many ways how can you achieve that background color is on the whole screen, and we will use the min height property and set it to 100 VH. VH is a relative viewport height, and by setting it to 100, you will achieve that the 100% of your screen window height will be affected with your properties. Save it and take a look. Great. Next, we will add display flex and flex direction to the column. By this, we define this main app element to be a container for the flexible blocks or different divisions in our case. Also, it gives us the flexibility to define where on the screen will our blocks be placed, how big will be the space between them, and so on. With a column direction, we said that these blocks or divisions need to be one under the other. Because we want everything to be at the center of the screen, we will add align items and justify content properties and put them in the center. When the flex direction value is column, align items sets the horizontal alignment and justify content vertical alignment. The last thing that we will add here is a font size. We will add calc and put in the brackets 10 pixels plus 2v min. This will calculate how big the font needs to be. In other words, the font will be adjusted regarding the dimensions of the screen window where it is placed. Let's take an example. Imagine that the screen size is Full HD. That means that your screen has 1920 horizontal pixels and 1080 vertical pixels. vmin will choose the smaller size of the viewport. In this example, it will be 1080 pixels. Number 2 in the front of vmin means that 2% will be multiplied by 1080 and the result will be 21.6 pixels. Calc function will add these two numbers and the result will be 31.6 pixels. Let's save the code and see current result. Now it looks much better than before. Let's move on the next CSS class, and that's the button list. As you can see, button list is in a Pascal case naming style. Pascal case is a programming naming convention where the first letter of each compound word in a variable is capitalized. You can use any naming style, but be careful, you need to be consistent with it. The general convention is a little bit unclear, but most of the developers are using hyphens in classes, so we can use a convention that was already used when we created a React app, and that was a convention with hyphens between the words. So let's change that, and now add it in the app.css file. Don't forget to add a dot before the class name, and be careful with big and small letters. The first property that we will add is padding, and we will set it to 25 pixels. That will create space around an element's content with a 25 pixels on each side. The second parameter will be background color, and we will set it to RGB. In the brackets, we will put 253, 67, and 67. Save and check it. Nice. Now we need to create an outer space for that division. So let's add margin with 40 pixels. Now let's round the corners. Add border radius with 48 pixels. And the last thing will be the width of 800 pixels. Save and check it. Awesome. Next, we'll experiment with the CSS styling of the component, and in our case, that will be the button component. It's not the best practice to change the CSS of the finished third-party component, but for the sake of example, we will see that this is one more possibility. Inside every button component, add a class name button, and also add that in the app.css file. The first property here will be a margin, and we will set values to 0, 20, 20, and 20 pixels. These four values represent different margins, and those are the top, right, bottom, and the left margin. Now add a height of 80 pixels and a width of 150 pixels. Save it and check it. Good. The last thing here that we want is bigger text inside the button. We will try to achieve it, not in CSS, but through the component property. So let's go on the documentation of that button. Type in the browser React Bootstrap buttons and click on the first link. Go to the API and find a property that changes the size of the button. You can see here that we can use SM or LG, and we will of course use LG because it means large, just as we wanted. You need to put that key value pair inside of the button component, not in the CSS file. Type size equals, and inside the quote marks, put LG. Save it and open the browser. And we are one step closer to our goal. The last thing in this section will be to style the slider. First, let's change a slider width. Here we will use the third possible way to style an element or a component. We will directly edit the CSS style inside the component. This is again not the best practice, but it is worth mentioning. Sometimes it's a lifesaver option, trust me. We will first go on the documentation and find under the API what we can do. And with a little bit of researching, we found out that we can override an existing CSS style with an SX property. The syntax here is a little bit different, so take a closer look at what I will do. Type SX equals double curly brackets width colon 800. The second and the last property will be default value, which is a native component property, so this time we aren't doing anything against the best practices. Type default value and then add a value of 100 inside of the curly brackets. Refresh the page. And now you can see that our slider has the default value of the 100%. Before we move on, I want to show you one cool feature that our browsers have, and that is Inspect feature. You can click F12 or right-click and press Inspect. Here you can temporarily edit the web page without affecting the source code. It is a great tool to play with CSS, debug your code, and it is the fastest way if you want to try a different font, size, or color. I recommend you to use it whenever you develop your frontend. It will save you a lot of time and sometimes give you an idea of what you can implement in the code. In that way, you can also inspect other web pages and get inspiration for your design. To return to the default styling, just press the refresh button and everything will come back to normal. At the moment, our application is fairly static. We can press buttons, move the slider, but they do nothing. We don't trigger any functions, nor do we send signals anywhere. Now let's dive into how we can react to user events and trigger the state to change. Each button element has an event which is called onClick, which triggers a function. Then this function can do everything what we want. Inside of the button component, type onClick with the capital letter of the word click, then equals, and open curly brackets. Inside curly brackets, you can give a name to your function however you want. We'll name it setRedBackground. Take a closer look at how we name it. We used a camel case styling because that's the general naming convention for the event handler functions in React. Now let's create a function inside our main app function right before the return statement. Type const setRedBackground equals, then empty brackets because we don't send any variable here, then arrow, which means equals and bigger than symbol, and open curly brackets. For testing purposes, we will add a console.log method, and inside that method, we will put in quotation marks a text "Red button has been pressed." Don't forget semicolon. Save it and open the browser. Press F12 to open Developer Tools and click on the console. Now press red button, and there you can see that we received the wanted message. If you try to press other buttons, you can see that nothing happens, because we didn't handle their events. Go back to the code and do the same for other buttons, just replace a red word with the correct words. We will also replace blue with yellow color. After we add all three functions, let's save it and check if everything works as we expected. And yes, buttons do work. Now we need to make a slider that works. The best way is to go to the documentation under the API section and see which functions the slider has. And after a while, we found out that getAreaValue text does exactly what we want. It returns a current slider value. Go into the code and inside of the slider component, type getAreaValue text equals, and inside of curly brackets, give a name to function setSliderValue. Again, we need to go up and define function. Type const setSliderValue equals open brackets, and now we will have a parameter called value inside those brackets, which type is a number. Then type arrow, open the curly brackets, and inside of them put console.log, but now put value inside of the brackets. Then in another line add a return statement. Then use backticks, put a $sign inside of them, and in the curly brackets put value. That will return a dynamic value to the component. Before we get further, I want to mention here that we just used a TypeScript syntax while defining that function's parameter needs to be a number. That is the main difference between JavaScript and TypeScript. In JavaScript, you don't need to define that. And this is their cons because sometimes when you are sending the wrong type, compiler does not warn you, and you need to debug every line of your code until you find that error. In TypeScript, you can be sure that in that function you will receive exactly a number, because compiler will warn you before you even start the application. Now let's save the code and see what is happening in the browser. As you can see, now our app is no longer static. We are finally doing something with buttons and sliders. In the next section, we will see how to save the state inside the Frontend application. Currently, we don't store anything in the Frontend application. When we press the buttons or move the slider, we only send that information to the console, and that information is lost. In this tutorial, we will use React hooks to manipulate states. But what are React hooks? React hooks are built-in functions that allow React developers to use state and lifecycle methods inside functional components. They are very powerful, and I suggest you to use them whenever possible. One great thing is that you can also create your custom hook. In this section, we'll use one of the most used React hooks, and that is useState. In the following section, we'll also introduce one custom React hook. Let's use our first useState hook. What we want to store is the background color of our button list division. Type here const, and open square brackets. Inside put color, comma, and set color. Equals, and type useState, and inside brackets and quotation marks, type 253 67 67. This red wavy line is telling us that something is wrong. Let's see what is the problem. It says that the name useState cannot be found. This means that we need to import that hook, and we can do that in few ways. The fastest way is to click on the useState to place an insertion point here and press Ctrl and dot at the same time. The quick fix window will pop up, and here you need to select the first fix, which is Update Import from React. Now you can see under the imports that we have successfully imported useState hook from React. Let's see what this state contains. The first color represents a variable where we store the value. setColor is the method that we will use to store the value. Inside of the useState, we define an initial value. This field can be empty, but then the variable will have an undefined state, which is sometimes dangerous. Now we can see those yellow wavy lines, which tell us that variable and method are still not used. Let's start with the method. It is logical that we call a method when the event occurs, and thus we will place that method inside functions which are triggered whenever someone presses the button. Inside the setRedBackground function, type setColor, and in the brackets and the quotation marks type 253 67 67. If you remember, those numbers represent the red color that we are using. Copy this whole line and paste it inside other functions. In the setGreenBackground function, change numbers to 132, 202, 19, which will set a color to green. In the setYellowBackground function, change numbers to 232, 213, 44, which will set a color to yellow. That is enough for now for this useState. Since we will use the slider for the setting the opacity of the button list background color, we will create another useState statement. So go ahead and type const opacity, set opacity equals useState, and put the number 1 as an initial state. Inside the setSliderValue function, type in the new line set opacity, and inside the brackets put value, and divide it with 100. We are doing this because we receive a value between the 0 and 100, but we want to store an opacity value to be between 0 and 1. But why are we doing that? Well, we need to change the background color and opacity at the same time somehow. In order to do that, we need to play with our CSS properties. This time, we will change the background color property. One way to do that is to use an RGBA function, which allows us to define a color, and an alpha value, which defines an opacity and needs to be between 0 and 1. So let's see how we will achieve that. First, let's add another useState. Type const background set background equals useState and as an initial state put RGBA 253 67 67 and 1. This will set the initial background to red and opacity to 100%. Let's use it in every function. Inside setSliderValue, type setBackground and inside brackets put backticks and type RGBA open brackets $, curly brackets and color, comma, $, open curly brackets, and value divided by 100. Compare my code to yours and make sure that everything is the same. It is important to mention here that these backticks, in combination with a $sign and curly brackets, are giving us a possibility to use variables dynamically. In other words, we are storing a string value in a dynamic way so that the string will always depend on the current value of the variables. You can also ask yourself here, but why did we use a color variable, which is useState variable, but not the opacity variable? Instead of that, we use the value, which is the function parameter. This is a good question. The answer is because when we save opacity here in that line, the value of the opacity variable will be stored after this function is executed. So, when we want to use background along with an opacity, if we use a value from the useState, we would use an old value. There are many things that can be done to tackle that problem, but in this example, we will stick with this way. Because of that, we will do the same in other methods. In the setRedBackground function, type setBackground brackets backticks RGBA brackets 253 67 67 $, curly brackets, and opacity. Here you can see that we can now use the opacity variable, but we manually set these color numbers. Do the same in other functions and match the colors. Great! Now let's use a background color in the button list division. In this example, we'll externally override CSS Styling by using style property inside of the div element. Remember, This is not a best practice, but we will use that for the sake of example and simplicity. Type inside the div style, double curly brackets, background color, colon, and background. Finally, save it and open a browser. We are currently setting parameters only locally, and in the next section, we'll see how to send signals to the backend. In this section, we will send signals from the frontend to the backend. We added 3 buttons and 1 slider in our frontend code. Every button needs to send a digital signal, and the slider will send an analog signal to the processor. Digital signal is basically a Boolean type, and an analog one is a number. In order to achieve that, first we need to install the ch5 Crestron components library. Go on the web browser and type npm Crestron components library and click on the first link. If you open a deprecated version, go on the versions section and choose the latest one. Then copy this install link go to your IDE and paste it in the terminal and press enter. In the meantime, if you didn't, install Crestron ch5 utilities CLI. Go back to the browser and type npm ch5 utilities CLI. Make sure that this is the latest version. If it is, copy and install link and go back to the IDE. The installation of the components library should be, in the meantime, finished. Now paste the command in the terminal and press enter. When it is finished, check in the package.json file if everything is correctly installed. As you can see, everything is just as we wanted. If we open a browser and type Crestron HTML5 developer, and click on the first link, we came to the official Crestron HTML5 documentation. In the left sidebar, click on the Advanced Programming, and then on Publish Events and send joins to a control system. Here you can find everything that is related with the sending signals to the control system, just what we need in this section. First, we will send a digital pulse, so we will focus on this section. You can see that this code is written in JavaScript, but we can get an idea of how we can use that code in our project. We are interested in these two lines of code. Let's see how it works. We recently installed Crestron Components library, so crcom-lib is nothing but that library. Publish event is one of the methods that we will use in that library, and this specific command sends signals to a control system. Inside the brackets, there are 3 parameters. Inside of the type parameter, you can choose between these 4 types. In our example, if you remember, we will use digital and analog signals, so we need to use Boolean type for the digital signal and number type for the analog signal. So for the first parameter, we'll set b and later n. The next parameter is the event signal name. If you already work with SIMPL, then you know what join numbers are. Basically, you can either use a string representation of a join number or a contract editor signal name. In this example, we will use join numbers for the sake of simplicity. The last parameter is a value that we want to send, so let's use that. Let's copy these 2 lines of code and paste them into the setRedBackground function. The signal indeed needs to be Boolean, so the first parameter needs to stay b. Under the second parameter, change the text to the string representation of number 1 and don't forget quote marks. Do the same in the next line. The third parameter is OK, because we want that when someone presses the button, the signal acts as a pulse. And as you see, it will be like that. The signal will be true just after this line will be executed, and after the next line, signal will again be false. Now copy these 2 lines, paste them into other buttons functions, and change a number to 2 and 3. Finally, copy just 1 line and paste it to the setSliderValue function. Here we need to adjust every parameter since we send an analog value here. The first parameter will be n as a number. The second will be 1 because this is analog 1 and it is not the same as digital 1, so there will be no clash between these 2 signals. The last parameter will be value. Save it. And we can see that now we have an error. This is because we didn't import it in the app.tsx file. We'll do one little trick and manually add a publish event from the library that we installed. So type import curly brackets publish event from in the quotation marks at Crestron /ch5 dash Crestron component library, and don't forget semicolon. By this, we are importing just a publish event method from the Crestron components library, and currently we need just that. Because of that, now we can remove the crcom_lib code because we are directly using publish event method that we imported. Try to save it. And we can see that no issues are found. Let's clean up a code a little bit. We will no longer need console.log parts, so let's remove them. Try to save it. Now it looks like everything should work. But I need to disappoint you. It will not. We can prove that by opening a web browser. Great, there is nothing on the screen. In order to make it work, we need to add 3 unintuitive things which are not described in the official Crestron documentation, but after that, everything will work correctly. The first thing is that we need to put a bunch of code around the publish event code. This time I will just copy and paste that code, but you can pause a video here so that you can rewrite it in your code. Make sure that everything is the same as in my code, especially the order of the code. The second thing is that we need to add an environment variable into our code. Let's create a file in the root folder and call it .env. Inside of the file, type with big letters public _URL equals quotation marks and inside of them dot. The third and the last thing is that we need to add one line of the code into the Crestron components library. Go under the node modules, add Crestron, ch5 Crestron components library, package.json. On the 13th line of code, copy this. Main build bundles /cjs /crcom_lib.js. Again, you can pause the video here and make sure that everything looks the same. This is actually a dangerous move because we are changing something inside of the node modules, and the general rule is that you should not do that. We are unfortunately forced to do that here. But potentially, one problem can occur. But I will explain in detail what the problem is and how to fix it in one of the next sections. Let's check if now we can see the page. Perfect, everything works fine. In the last section, we prepare the code for sending signals to the processor. In this section, we will find out how to receive signals from the processor. we will receive one analog and one serial signal. The process could be the same. We could go on the Crestron developer website and find the function for receiving signals. But I want to show you a second way of how you can achieve that. Remember React hooks? Now we will use the custom React hook. But we don't want to reinvent the wheel, so we will use an existing hook which is made by Damien Butt from Norgate AV company. So go ahead and type in Google npm.js norgate-av React hooks. Click on the first link. Here we will use this install link, but first let's see how to use the hook. Basically, we need to import one of the available hooks and then we can save it in the variable. When the signal will come, the variable will store the value and then we can use that variable however we want. By the way, thank you Damien for these hooks. You rock! So let's copy that link and paste it into our code. We can see that error appears, and if we carefully read the description, we can see that the React dependency, which is the part of this dependency, is version 16, and we are locally using version 17. There are two possible solutions to fix this problem. The first one is that we can upgrade the dependency inside the React hooks project. We can do that by forking the project on GitHub and in the package.json change the version of React to match our version. The second solution would be to add a force command to the existing installation command, and in that case, we can say something like, "Okay, we know that anything bad will not happen, so we will take the risk." Even if the first solution is better and cleaner, this time we will use the second solution because I'm sure that it will work. I strongly encourage you that in situations like this, you think twice about what you should do, and I suggest that you are using the first solution for real-world projects and the second solution when you are quickly testing something. So let's type the command once again and add a -f. This time, the dependency is installed, and now we can start to use it. We can find out which hooks are available by going to the folder where they are installed. Click on the node modules, Norgate AV, React hooks, dist, hooks, Crestron, and here you can see what we have. Since we need to receive analog and serial signals, we are considering subscribing to the serial and analog signal, so we will use useSubscribeAnalog and useSubscribeSerial hook. Let's import that. Inside app.tsx file, under the publish event import, type import curly brackets useSubscribeAnalog comma useSubscribeSerial from at Norgate AV / React hooks semicolon. Inside app function add const opacity value equals use subscribe analog brackets quotation marks 1. In the next line, const text response equals use subscribe serial brackets quotation marks 1. And don't forget semicolon. The number 1 represents the join number. We will receive an opacity value from the backend just for testing purposes. Basically, we could just use the opacity value from the use state, but for the sake of example, it is a good way to see if it works and how quickly transmission of the current state is. The text response will be the text which will give us a description of the background color of the button list. The backend will do the logic behind that. So let's add these responses somewhere. Copy opacity value and go down under the opacity paragraph. Add a colon after the opacity, and then in the curly brackets paste opacity value. After brackets, add a %. Remember that if we didn't add curly brackets, opacity value would be just an ordinary text. By adding the variable inside the curly brackets, we are using a dynamic value from the variable. Next, replace a background color paragraph with curly brackets, and inside them put text response. In this way, the text will be dynamic, and we will wait until we receive some response from the backend. But here we need to anticipate one situation. We need to discover which are the initial values of these two variables. The opacity value is an analog signal, and the initial value for the analog signal is 0. The text response is a serial signal, and the initial value for the serial signal is an empty string. Neither of the values is what we want to have for the initial values until we receive a response from the backend. We want that the initial background color for the button list division is red and that the slider is on 100%, so on the full right position. In other words, we want that the string is red background color and that the analog value is 100. We can do that by adding basic conditions to the code. Let's see what we can use for the condition logic. The initial analog value is 0, but at some point we will use the value 0, so we don't want to mess with it. The initial serial value is empty string, and we definitely do not want to have an empty string on the screen, so we can use that value for the condition logic. We won't use a standard if-else statements, but we will introduce a ternary operation. This is basically a shortened version of the if-else statements, and it will perfectly do the job in our case. The ternary operator takes 3 operands: a condition followed by a question mark, then an expression to execute if the condition is truthy followed by a colon, and finally the expression to execute if the condition is false. Let's implement it by adding a ternary operator in the background color paragraph. Type text response quotation marks, question mark, quotation marks, inside red background color, colon, text response. Let's analyze it. If the text response is the equal empty string like it is at the beginning, and before we send some signal to the backend, then the initial text needs to be red background color. If it's not an empty string, then we can use the text which we received from the backend. We can do the same for the opacity value. I will copy a code that I recently wrote and paste it in the opacity paragraph between the curly brackets. The condition will be the same. If the text response is empty, that means that you need to set an initial opacity value, and that needs to be 100. If this is not true, that means that we received an opacity value, so under the third operand, we need to put opacity value variable. And we successfully added everything what is needed to receive signals from the processor. Before we start to write the backend code, in the following two sections, we will see how to fix a problem that we have in the Node modules and how to deploy a code to the touchscreen directly from the IDE. In this section, I will talk about Node modules, GitHub, and teamwork. We will also patch a broken dependency that we temporarily fixed in one of the previous sections. Let me explain a little bit what Node modules are. Node modules are external modules that your project depends upon. They are downloaded from the web and copied into the Node module folder, and Node.js is trained to look for them there when you import them. They usually take up the most space on the project. By most, I mean 95% or more. In our example, Node modules takes around 305 megabytes and other files just around 8 megabytes. What does that mean for us and why is that important? Well, now we are coming to the part about teamwork. Imagine that you're working in a team and you want to share the code with them. This is usually done by publishing your code on the remote repository, such as GitHub. But it would be pointless if you would need to upload all of your code to GitHub, including a Node modules folder, because altogether has 313 megabytes. Instead, you could just upload all the other files, which are just 8 megabytes weight. And actually, we're doing that. Remember the package.json file? Inside of that file, we are declaring which versions of dependencies should be downloaded from the internet. Now, let's see what is happening in this animation when we publish and clone the project from GitHub. When you wrote some code and you're ready to share it, you usually publish it to the GitHub repository. Firstly, GitHub is looking for the gitignore file. Inside of that file, under the dependencies, you can see that you want to exclude Node modules, so you push everything except these few folders that you have in the gitignore file. Once your project is available on GitHub, your colleagues can clone the code to their local machine. When the code is cloned, the command npm install needs to be executed. In that case, your IDE is looking at the package.json file and downloading the listed dependencies from the internet. Finally, you and your colleagues have the same code and you don't need to upload the Node modules to GitHub. That's awesome! And frankly, it is. Except when you need to change something inside the Node modules. How can your colleagues know that you did change something inside the Node modules? Of course, you can tell them, or write an email to them. But this is not a good practice at all. Do you remember what we did in our Node modules? We added this one line of code into the Crestron components library. If we publish that code on the remote repository, our colleagues will not have the same code and nothing would work for them. In order to make it work, we need to add something in our code that will automatically tell the IDE that while it starts installing dependencies, it needs to add one or more things to them. So let's see how can we fix that problem. Open browser and type npm patch package. Click on the first link. Under the versions, click on the latest version. And here we have a patch package that will fix our problem with Node modules. You can, of course, read the whole documentation if you want to know more about it. Let's copy that code and paste it into the terminal inside of the IDE. After that, type into the terminal npx patch-package at Crestron /crcomlib -exclude. This command will look at the Crestron components library and generate a code that will tell us what we added to this library. You can see that it generates a patches folder, and if we open a file inside that folder, we can see that the changes are made in the package.json folder of the Crestron components library, and that this line was added here. After that, open the package.json file and under the scripts, add following. Quotation marks, post install, colon, quotation marks, patch-package. This will make that after the npm install command is executed, patch package run patch and add differences that we made into the Node modules folder. And that's it, our code has been fixed. If we want to be sure that it works, we can delete the Node modules folder and package log.json file and run npm install. So let's do it. Now run npm install -f. Now go to the Node modules and find a Crestron components library package. Open package.json. Perfect, we did it! And now it's time for the last frontend section. In the next section, we'll write scripts that will deploy our code to the touch panel. Stay tuned! Since we are finished with the frontend part of the project, we are now ready to deploy a code to the touchscreen. It is always good to have scripts that speed up any kind of process. We can see here that we have the npm scripts section. These are scripts that exist in the package.json file, so let's open that file. So far, we used a start and post install script, and now we are gonna add some new scripts. In order to deploy a code, we need to do three things: build a code, build an archive, and deploy that archive to the touchscreen. Now let's find the right documentation in which we can find more information about that. Open the browser and type Crestron deploy ch5. Click on the first link. Here you can find any details you need, and I encourage you to read that documentation on your own. Let's go back to the code. As you can see, we already have the build script. Now we need to create a script that builds an archive. So let's type in the next line: build :archive ch5 -cli archive -p ch5 -react -p sample source equals ch5 -react -d build -o dist. With this script, we will archive a project with the name of ch5-react and place that archive into the dist folder. Now let's add a deploy script. Type in the new line the following: deploy ch5-cli deploy -p -h IP address -t touchscreen dist /ch5 -react .ch5z. Now you can replace IP address part with an IP address of your touchscreen. Mine is 192.168.1.101. This script is using an archive from the dist folder and sends it to the IP address that you wrote. -p part means that our touchscreen is password protected, so we will need to type in the password when it will be needed. And that's it. Now we can run all three scripts one by one. But we won't do that. We are lazy programmers, aren't we? We want to have a script that will do all at once. And yes, we will achieve that. So let's type in another line: deploy :1-step :npm run build end npm run build :archive end npm run deploy. As you can see in the code, we are basically running all three scripts one by one. Awesome! So let's try this. First, we need to save the code. Under the npm scripts, choose deploy one step and press run. You can see that build folder has been created. And now the dist folder has been created. Here I need to type username and password. Press enter and wait until it's deployed. Finally, we successfully deployed a code to the touchscreen. Let's see what it looks like. As you can see, everything is working as we expected. We are finally finished with the frontend part. Now it's time to jump on the backend. See you in the next section. I assume that you watched videos on the Crestron CTI portal regarding setting up the environment, so I won't go into the details. Firstly, let's create a folder on the desktop and call it S Sharp Pro app. Open your preferred IDE. I will use Visual Studio 2022. Click Create a new project. Under the languages, choose C# and in the search bar type class library. Choose this one with the .NET framework and click Next. Our project name will be SIMPL Sharp Pro app, written in Pascal case. Under the location, find the folder location that you just made. Under the framework, choose 4.7. Click Create. Under the Solution Explorer, right-click on the project name and choose Manage NuGet Packages. You can also find it under the project drop-down. Click on the Browse and type Crestron. Choose SIMPL Sharp SDK program and click on the Install button. Then click OK and I accept. You can see that a new class has been added to your project. You can now remove this initial class 1 from the project. Now let's go inside of the control system class. It would be nice if we could make our code a little bit easier to read. In order to achieve that, click Ctrl+M and Ctrl+O, or you can click on the Edit, Outlining, Collapse the definition. This will collapse comments and functions so that we can focus just on what we need at this moment. We will only initialize the system, so expand only this function. Now we need to initialize all the Crestron equipment that we will use, besides the processor. In this tutorial, we are only using TSW 1060, so let's initialize it. If you have any other equipment, you can also initialize it. At the top of the class, we need to declare the library that we'll use, and that is the UI library. You can notice that in React we used an import statement, and here we are using the using statement. So let's type using Crestron dot SIMPL Sharp Pro dot UI. We will make a comment here and type / for touch panels. Now we can make a TSW container inside our class. You need to type here TSW1060 and we will call it my touch panel. Let's initialize it. Inside these brackets, type my touch panel equals new TSW1060, open the brackets, and here we need to give two arguments. The first will be IP ID and we will set it to 3, but hexadecimal, so type 0x03 as a first argument. In the second argument, we need to specify the part of which control system will be the touch screen. Here we will type literally this, since it will be the part of the control system where this code will exist. After that, we need to register the touch panel and do certain things in the case that it is successfully registered. Type if, open the brackets, my touch panel dot register brackets double equals E. And now you can see how IntelliSense are giving us in the most cases the correct advice, so we can just accept this long word by pressing enter. Now type dot and success. Open the curly brackets, and inside them we will specify what needs to be done when we receive a signal change. Type my touch panel dot sig change plus equals, and now press tab. This will automatically create a function where we will define all the logic that needs to be done when we receive a signal change. Here we can remove this line because we won't use it. And now we are ready to implement the logic. But we will do that in the next section. If we look from the backend perspective, we are receiving 4 signals from the frontend. 3 of them are digital signals from the buttons, and 1 is the analog representation of the opacity value, which we are controlling with the linear slider. On the backend side, we need to consume that information, and depending on the values we get, we have to give back the response. One response needs to be an analog value, which will be the same analog value that we receive from the frontend side. We could, of course, do that on the frontend side, and even if this makes no sense that we are returning the exact same value, in this example, this will show us just how fast or slow the process is. You should avoid that in real-world applications because it consumes resources unnecessarily. The second response will be serial value, and that will be the text which will describe the background behind the buttons. Depending on the pressed button, we will save the text which will represent the color in the variable background color text. Also, depending on the analog input, we'll create a background transparency text which will tell us how transparent the background is. Finally, depending on the combination of the digital and the analog inputs, we'll create a title that we will send as a serial response. Here you can see every possible title that can be made. The default analog input will have 100% of the opacity, and the default digital input will be number 1, which represents the red button, and that means the default title will be red background color. With that table in our mind, let's go and write the code for that. We'll define 3 variables and place them under the MyTouchPanel container. For the first variable, type private string background color text, and for the initial value, set the string red. Then, in the new line, type private string background transparency text with an empty string as an initial value. In another line, type private uShort background opacity and set a value to 100. Now we are ready to implement logic. First, we will examine if the signal which has changed is Boolean, and if that change is the rising edge of the signal, then we will set the background color text depending on the button which has been pressed. Inside the function myTouchPanel_SigChange, type if, open the brackets, args dot sig dot type double equals eSigType dot bool double end args dot sig dot bool value double equals true. Open the curly brackets. You can now see that the first condition is testing if the type of the changed signal is Boolean, and the second condition is testing if this is a rising edge of the signal. In other words, if the condition of the signal is currently true. Double AND means that both conditions need to be true so that the code inside of the if function can be executed. It is the same as the logical AND. Type switch, open the brackets, and inside type args.sig.number. Open the curly brackets and type case 1 colon. In the next line, set the background color text to red. And in the line below, type break. Let's just type here in the comment that digital 1 was pressed so that we know what we have done. Now copy the case 1 and paste it twice. Here we will change number 1 into number 2. As well as here, and under the text, we will type green. Here we will do the same, just we will type 3, and under the color, type yellow. So what have we done here? Besides the value, the signal contains few more information. Thus, here we can examine which is the number of the signal and then set the text value according to that. With that, we are for now finished with digital signals. Now we will write the logic for the analog signal. Type else, if, and open the brackets. Inside of the brackets, we will also have two conditions. With the first, we'll examine if we received an analog value, and with the second one, we will see if that is an analog signal number 1. So type args.sig.type equals eSigType dot uShort double and args dot sig dot number double equals 1. We'll put a comment and type analog value has been received. Open the curly brackets. As I mentioned before, first we will save a value into the variable and then just send it back to the frontend. With that, we'll see how fast or slow our code is and if we can count on that speed in some of the future functions. Type background opacity equals args dot sig dot uShort value, and in the new line type myTouchPanel dot uShort input square brackets 1 dot uShort value equals background opacity. Now let's compare the background opacity value and set the background transparency text according to the conditions that we already wrote in the table. Type if background opacity equals 0, then myTouchPanel dot string input square brackets 1 dot string value equals quotation marks transparent background. Else if background opacity is less than 50, background transparency text equals very transparent and space. Then, else if background opacity is less than 75, background transparency text equals slightly transparent and space. And finally, else myTouchPanel dot string input square brackets 1 dot string value equals background color text plus quotation marks space background color. Let's see in the table which combinations we covered. We covered the whole first line and the last line. Now we need to cover the analog values that are greater than 0 and less than 75. In that case, we need to combine background transparency text and then add a background color text variable. So let's do that. Type if, open the brackets, and put background opacity not equal 0. Double and background opacity less than 75. Open the curly brackets and now type my touch panel dot string input square brackets 1 dot string value equals background transparency text plus background color text semicolon. And with that, we covered every possible situation and we are finished with the backend logic. We reached the final phase of this tutorial, and that means that it's time for building the backend project and uploading it to the processor. In Visual Studio, click on the Build dropdown and click on the Build solution. This will, among other things, generate a CPZ file which will be uploaded to the processor. When the build is finished, open the browser and type the IP address of your Crestron processor. If you don't have a security certificate, then you will probably get a similar page. Click on the Advanced and then click on the Proceed to your IP address. Now you need to type your username and password. You should see a similar page depending on your processor. I'm using RMC4, but the process is not so much different from other processors. Click on the Settings. Then open the Program section. And under the Program Editing column and in row 1, click on this Upload Program button. Click on this button. And now you can drag and drop a CPZ file here, or click on the Browse and find the CPZ file. Let's do the latter. The CPZ file is under your Program folder, under the Bin, and then Debug folder. Click on the file and press Open. Click on the Load button. And the file is uploaded. Let's go and check how it looks and behaves. And we made it! Congratulations! We can see that everything is working as we expected. You can also see that the opacity value is pretty synced with the slider, which means that in some situations we could count on the processor speed. All in all, I'm very happy with the final result. Now it's time to make a conclusion and see what could be our next moves. In this tutorial, we successfully combined two development technologies that are highly used in the general web development industry. The goal was to detect and clear all the problems that could be on our way to make communication between the touch panel and the processor with React on the frontend and SIMPL Sharp Pro on the backend. To be honest, I spent more time and effort explaining what we have done on the frontend because of one simple reason. And that is because there are not many resources available on the internet where you can find information about using React with Crestron. On the other hand, Crestron Technical Institute did a great job explaining how to use SIMPL Sharp Pro, so my goal was not to focus on the backend. Have in mind that everything we have done in this tutorial is made just to show you all the possibilities and to make a decent starting project where you can later add new features, libraries, implement some other cool stuff, etc. We haven't said anything about project architecture or project structure, so now it's your turn to find the best practices and methods that can make your code clean, sustainable, and scalable. Today, technology is advancing very fast, so it is always good to be in touch with the latest technologies and best practices. On the other hand, some principles will always stay the same, so it's not bad to read books like Clean Code and Clean Architecture by Robert Martin, more known as Uncle Bob. I have made a list of the terms that I think are very important. I think that they are crucial if you want to become a good React and SIMPL Sharp Pro developer and, in general, a great Crestron programmer. Regarding React, I suggest you study how to use components, which will make your code to be reusable and cleaner, React Router or its alternatives, which will allow you to have more independent pages, React State Management. The good question is, do you always need to call the backend or can you do some things with the states on the frontend? React hooks. We have only covered the use state, but there is a lot more to learn. Third-party component libraries. We added just 2, but there are hundreds and hundreds of component libraries that you can use. Sometimes you really don't need to reinvent the wheel. Advanced CSS. This is always good to know because it gives you infinite freedom to style an UI. Regarding SIMPL Sharp Pro, I suggest you study what are design patterns and design architectures. This is a must if you want to create scalable and maintainable applications. Advanced object-oriented programming, how to work with WebSockets, to communicate with touch panels or other control devices. How to send and receive objects in the JSON format. How to work with SQL databases. If you manage to learn and implement all these things, I'm sure you would be able to solve any complex problems. The good news is, all of those things can be found on the internet for free. So I highly suggest that if you want to become a world-class Crestron developer, to start looking in that direction. At the end, I just want to thank you for watching this course, and I encourage you to write in the comment section which topic do you want that I cover next. Also, if you have any suggestions, please do not hesitate to express your opinion. If you enjoyed this video, please press the like button, subscribe to my channel and click on the notification bell so you can be notified when the new video will be released. Until then, stay safe and see you in the next video.